Bismillahirrahmanirrahim. Welcome to my channel Science of Life with Dr. Mohammed Yusuf. Today I am going to talk about the functions of plasma protein. But before that, one hadith I would like to quote. Huzur Sallallahu Alaihi Wasallam मुबारक इरशाद फरमाते हैं इज़ा रअयतुमुर रजुला यतआदुल मस्जिद फशहदू लहू बिल ईमान फ़इन्नल्लाह यक़ूलु इन्नमा यामुरु मसाजिदल्लाहि मन आमन बिल्लाहि वल यौमिल आखिर। हुज़ूर सल्लल्लाहु अलैहि वसल्लम फरमा रहे हैं कि जब तुम किसी शख्स को देखो कि वो मस्जिद की खिदमत और निगहदाश्त में लगा रहता है, उसका मस्जिद के साथ मुताल्लिक है, तो उसके ईमान की शहादत दो। इसलिए कि अल्लाह ताला ने कुरान पाक में फरमाया है कि इन्नल्लाह यामुरु मसाजिदल्लाहि मन आमन बिल्लाहि वल यौमिल आखिर, के अल्लाह फरमाता है कि मस्जिदों को आबाद वही लोग करते हैं जो अल्लाह और यौम आखिरत पर ईमान रखते हैं। तो ये एक निशानी है, मस्जिद के साथ ताल्लुक़ ईमान की निशानी है। अल्लाह पाक हमें समझ अमल की तौफीक दे। So we will talk about the functions of plasma protein. In the first lecture, we saw that the plasma protein, very important components of plasma. The total concentration of plasma protein is 6 to 8 grams per deciliter. 6 to 8 grams per deciliter per 100 ml of blood. There are three types of plasma proteins. Albumin, number 1, 2 is globulin, and 3 fibrinogen. And total concentration of all these three is 6 to 8 grams per deciliter. The albumin, concentration of albumin, this is the most abundant molecule amongst the proteins. Albumin, the concentration ranges between 4.5 to 5 grams per deciliter. And the globulin is 2 to 3 grams per deciliter. Fibrinogen only 0.2 to 0.45 gram per deciliter, 0.2 to 0.4 gram per deciliter. Some very small amount of fibrinogen. Most abundant is albumin, and then is the globulin, Ag. Albumin and globulin, they are usually collectively called as Ag. Ratio between the Ag, 4 to 2 is the ratio between the albumin globulin Ag ratio. The globulin is further divided into many fragments. That is alpha 1 globulin, and then alpha 2 globulins, and then beta 1 globulins, beta 2 globulins, and then gamma globulins. So these are the 5 important fractions of the globulin. So total concentration is 6 to 8 grams per deciliter. Total plasma 6 to 8 grams per deciliter. Now the function, before we can discuss the individual function, I am going to just list the different functions of the plasma protein. Very important function. Probably the most important function is the plasma protein. They provide the osmotic pressure. One of the very important force which determines the transport of fluid across the capillary membrane. There are 4 forces there which are collectively known as Starling forces. Very important force amongst those is the colloid osmotic pressure. So the plasma protein, they provide colloid osmotic pressure in the plasma. Then the plasma protein, they are very important buffer. They maintain the pH. They resist the change in pH. And they have got the important functions of transporting of different substances. For example, transport of hormones and transport of metals. And amongst the plasma protein, there are several proteins which are involved in the blood clotting mechanism. So clotting factors are also plasma protein. Most of the clotting factors are plasma protein. Then there are some factors which prevent the coagulation. In intravascular coagulation should not occur. The clotting should occur, will only occur when there is bleeding, when there is some damage to the blood vessel, then the clotting will occur. But inside the blood vessel, intravascular clotting must be prevented, and there are anticoagulants, which are some plasma proteins, anticoagulants as well. Then the proteins are very important. Nutrition, so they provide the nutrition as well. Then very important function, immunity. The gamma globulins, amongst the globulin fraction gamma globulin, they are important in the imparting immunity to the body. So antibodies are immunoglobulins and they are plasma proteins. Then plasma protein, they give viscosity, they contribute toward the viscosity of the blood. And then there are some enzymes. Enzymes are usually proteins, and there are some enzymes circulating in the blood performing different reactions, and so enzymes are also part of the plasma protein. And then there are circulating hormones as well, which are proteins. Protein hormones, all the hormones, they are circulating in the blood. So protein hormones are also circulating in the blood. So plasma protein, amongst there are hormones as well. Then there are some substances in the protein, plasma protein, which are converted into some very important active substances which perform their function in respective system. For example, so they are known as substrate for the renin. Angiotensinogen is a very big protein which is converted into renin, and then renin is it is acted upon by renin, and it is converted angiotensinogen 1, angiotensin 1 and angiotensin 2. We will discuss its function, and probably if you can see my lectures on circulation, I have discussed the functions of angiotensin 1 and 2 there in the circulation. So this is a plasma protein, angiotensinogen, which is the substrate for renin for the formation of angiotensin 1 and angiotensin 2. So this is the general list of the functions of the plasma protein. So individually we will take this function one by one. Nutrition, for example. Plasma protein, everywhere. Plasma proteins, they break down into amino acids, and these amino acids can be supplied to all the cells of the body. All the cells are synthesizing protein for their functions. All the enzymes are the structural cells and the cellular cytoplasmic proteins. So they are synthesized from the amino acids. So plasma proteins are circulating. They can be easily converted into, they can be broken down into amino acids, and these amino acids can be utilized by any cell in the body. So nutrition. So these plasma proteins are constantly being synthesized in the liver, and they can be provided to all the cells of the body, but all the plasma protein synthesis occurs in the liver. And this turnover of these plasma proteins, for example, albumin, it is 10 to 12 grams of albumin turnover occurs in 24 hours. Liver is synthesizing about 12 grams of albumin daily. So daily new albumin is being formed, and old albumin is being replaced. That is being utilized for different functions. For example, nutrition, they can be utilized. So liver is producing the proteins, and they can be utilized anywhere in the body. The viscosity, in the list we saw, viscosity, blood is 5 times viscous than water. And most important factors in the determination of the blood viscosity we'll discuss in the previous lecture, those are RBCs. But plasma protein, they do contribute towards the viscosity. Proteins contribute towards the viscosity of the blood. All the macromolecules contribute more for this purpose. The bigger the particle, more will be the contribution of that particle for this viscosity. So these proteins are macromolecules. They are big, long chains of the amino acids, and so they are big molecules. They contribute toward the viscosity. Excessive viscosity if can occur due to any reason, probably usually with excessive viscosity occurs due to the polycythemia, very high number of RBCs that causes more viscous blood, and that may cause the impediment to the blood flow in the blood vessels, clogging of the blood vessel, more viscous fluidity, the flow is reduced, impediment to the flow occurs if the blood is more viscous. Now, this important factor is osmotic pressure. All the protein osmotic pressure, it is the suction force. It osmotic particles which cannot penetrate the capillary membrane, they remain in the blood. They have got the they can retain the water inside the blood. So these plasma proteins are very important for this purpose. They retain the vascular compartment fluid. So osmotic pressure, they exert 28 millimeter of mercury osmotic pressure. Their total osmotic pressure by the plasma protein, by 6 to 8 grams of the plasma protein, is 28 millimeter of mercury. As we saw, the concentration of albumin is the maximum. That is 4 gram per deciliter, 4 to 5 gram per deciliter is the concentration of albumin in the blood. Most abundant protein is the albumin, and so it contributes more. 80% of the this osmotic pressure is provided by the albumin only. The reason is that it is the most abundant molecule amongst the plasma protein, plus the size of the molecule. Albumin is the smallest protein. Globulins are bigger protein, and fibrinogen is a very big protein. And the viscosity, the osmotic pressure, it depends upon the number of particles present. So the per grams or per gram molecular weight of albumin, number of particles is tremendous as compared to the fibrinogen or globulin. So it is a smaller molecule and most abundant molecule. So that's why it contributes 80% of the total osmotic pressure, which is about 28 millimeter of mercury. Most abundant protein and smallest molecule. So number of molecules are tremendous, and so they provide the osmotic pressure. Number of molecules per unit of weight is tremendous albumin. So this provide. Whenever there is hypoproteinemia, when there is decreased amount of protein due to some liver disease or due to some malnutrition or due to some abnormality in the kidneys, proteins are being lost in the urine, the proteins deficiency may occur. It is below 6 gram per deciliter, 5 gram, 4 gram per deciliter. If the plasma protein are deficient, that is known as hypoproteinemia. So this osmotic pressure will be reduced, and this is the retention force for the water inside the vascular compartment. If the plasma proteins are deficient, if there is hypoproteinemia, then the water will ooze out, will come out, will be filtered out of the capillaries, and it will collect in the interstitial spaces, and that increased amount of the interstitial fluid is known as edema. So the hypoproteinemia results into generalized edema because of the low osmotic pressure. So all the condition in which there is hypoproteinemia, for example malnutrition, for example liver disease, for example the kidney diseases which cause the excessive loss of your proteins in the urine, in all those conditions osmotic pressure is reduced, and edema is very common feature of hypoproteinemia. Then the functions of carrier. Plasma proteins are carrier of many substances, carrier of the albumin, transports bilirubin. Bilirubin is the breakdown product of hemoglobin. Hemoglobin in the RBCs have got the lifespan of 120 days, and after 120 days RBCs are destroyed and their hemoglobin is degraded, and in that degradation bilirubin is formed, that yellow pigment in our blood. So bilirubin is transported by the plasma, this albumin, to the for the excretion. So albumin is transported by the, in combination with the albumin. Different hormones, some hormones are transported by the plasma protein. We are going to see there are globulins as well, and albumin also transports the hormones. Drugs some chemicals. We take intake of drugs, so there are some drugs which are distributed throughout the body, and plasma protein is responsible for the carriage of some of the drugs we take. For example, for the transport of hormone, there is thyroxine binding globulin, and pre-albumin carry the thyroid hormone. Thyroid hormone combined with the albumin and pre-albumin, and even the globulin as well, globulin, thyroxine binding globulin as well. So transport functions of the plasma protein. Hormones are transported, drugs and bilirubin is transported. There is a protein that is named as transcortin, that is the plasma protein transcortin, which carries cortisol. Cortisol is a hormone produced from the adrenal cortex that is carried by the transcortin, that is again albumin. And then lipoproteins carry lipids. You know the name of the lipoprotein they are carrying. They are in combination with the different forms of the lipid, triglycerides, and even the cholesterol in combination with the protein. So they are known as lipoproteins. There are different types of lipoprotein we will discuss at proper times. Then there is a protein which carries copper. That is a special protein which is known as ceruloplasmin. That is one of the plasma protein which is responsible for the carriage of the copper in the blood, so ceruloplasmin. And then for iron combining protein in the plasma is the transferrin, which carries iron. Iron is being carried in the blood with this protein. So carrier function is the very important functions of the proteins. Haptoglobin binds with the free hemoglobin as well. Free hemoglobin doesn't exist in our blood. Hemoglobin is usually in the RBCs. But if RBCs breakdown of the RBCs may occur, hemoglobin is also degraded, but some hemoglobin may be present in the plasma, maybe free hemoglobin that can combine with the haptoglobin. And then this importance of this combination is, this combination of hemoglobin with the plasma protein, this is again a protein. Hemoglobin itself is a protein, but it is a small protein. If it is present in free form in the plasma, it will be filtered in the glomerulus in the kidney, in the nephron. And this filtration of hemoglobin may cause the precipitation of hemoglobin in the renal tubules, and it may cause the renal shutdown. That is a dangerous complication of the hemoglobin present, excessive amount of hemoglobin, free hemoglobin. So free hemoglobin, if it is available, albumin combined with it, or the haptoglobin combined with it, and it is not filterable then at the glomerulus. It cannot be filtered there. So there is transport protein for the hemoglobin, which is known as haptoglobin. So carrier protein, there are many carrier proteins. Then another functions of the plasma protein, most of the clotting factor. We will discuss this clotting mechanism in this hematology. The most of the important clotting factors are proteins. They are part of the plasma protein. Most of the clotting factors are part of the plasma protein. For example, we will discuss all these factors. We are just listing, I am just going to list the protein clotting factors. Fibrinogen, for example, very important. Final clot is the product found from the fibrinogen. Fibrinogen is converted, probably I projected a picture of clot. What is clot? It is the fibrinogen is converted into fibrin threads, and those thread meshwork or network of those thread is known as clot. So fibrinogen is the clotting factor number one. And then there is a prothrombin, another clotting factor. And then there is labile factor, another clotting factor. All these are proteins, plasma protein. Then there is stable factor. We will discuss the functions of these when we discuss clotting mechanism. So stable factor, a plasma protein. And then the anti-hemophilic globulin factor, AHGF, anti-hemophilic globulin factor. It is just abbreviation, but you must be knowing that the hemophilia is a disease in which this clotting factor is absent and the person bleeds more. So it is anti-hemophilic globulin factor. It is a protein, plasma protein. And then there is a Christmas factor. and that is also plasma protein. And then stored Proer factor, one of the another clotting factor, that is the plasma protein. Hagman factor, Hagman factor, plasma protein. Then fibrin stabilizing factor. Fibrin is formed from in there, and stabilization of that is caused by this another protein in the plasma, that is fibrin stabilizing factor, FSF. So all these are the clotting factors. Important clotting factor, which we will discuss in detail when we discuss the clotting mechanism. So plasma proteins, they provide the clotting mechanisms as well. And anticoagulants, they are also plasma protein. For example, important heparin and the antithrombin. Antithrombin is a very important plasma protein which prevents the intravascular clotting. Blood does not clotting in our vascular compartment. It should not clot. So this clotting is prevented by the anticoagulant. They are also the plasma proteins. Then buffer functions of the plasma protein. Plasma proteins, buffer is the something which resists change in the pH. pH is maintained by buffer. The 15% of the buffering capacity of the blood is due to the plasma protein. Very important buffer in the blood is hemoglobin. We will discuss the functions of hemoglobin in some other lecture. But the biggest buffer in the blood is the hemoglobin. But the plasma protein, they provide 15% of the total buffering capacity of the blood. And amino acids are, usually amino acids, they exist usually in the form of what we call is zwitterine, double charge particle. One part of the molecule is positive, another part is negative. This such molecule is known as zwitterine. You must have studied in organic chemistry. So amino acids in the zwitterine state, they act as the buffer, because they can, negative side can accept the hydrogen ion and positive side can donate the hydrogen ion. So the zwitterines, they are important in buffering mechanism. So at normal pH of blood, we saw in the previous lecture as well, normal pH of blood is 7.4. That is, mostly the proteins are in the negatively charged proteins at this pH. That is 7.4 pH, slightly alkaline proteins, plasma protein, most of them, they are negatively charged and they can combine with the cations, especially hydrogen ion. Hydrogen ion can combine with it, so they are buffering power has. So the plasma proteins are very important buffers in the blood. Immunity, the defense system of the body against the different diseases. Antibodies are formed against the different antigens, foreign invaders, foreign particles, foreign proteins against which the body can produce antibodies. And antibodies are the gamma globulins, amongst the fifth fraction of that globulin. हमने slide में देखा था. That is, gamma globulins are responsible for imparting immunity, and antibodies are gamma globulins, and they are also known as immunoglobulins. And there are different types of the immunoglobulins. We will discuss in detail when we discuss the immunity in detail. Different immunoglobulins, there are 5 types of the antibodies, or 5 types of immunoglobulins imparting immunity. IgG, immunoglobulin G, and then IgM, then IgA, and then IgD, and then IgE. These are the 5 different types of the antibodies. We will discuss all these types of antibodies when we discuss immunity in detail, inshallah. So the plasma proteins are important for imparting immunity in the body. Then precursor for the active substances of this plasma protein, that is some very important proteins present in the inactive form as part of the plasma proteins, and they are activated to very important specific functions. For example, angiotensin is formed from the angiotensinogen by the actions of the renin. Renin substrate is the angiotensinogen. So angiotensin is formed from these precursors. And erythropoietin, a very important protein for the regulation of the formation of RBCs, erythropoietin, we are going to discuss in next lecture, inshallah ta'ala, when we talk about the erythrogenesis. So angiotensin and erythropoietin, and there are some kinins which have got the actions on the blood vessels as well. So these are the important substances, the precursors of which are present in the part of the plasma proteins. And then the plasma, amongst the plasma protein, there are circulating hormones as well, and many circulating protein hormones are the part of the plasma protein. For example, growth hormone produced from the anterior pituitary, and then the parathyroid hormone produced from the parathyroid gland, insulin, very important hormone produced from the pancreas, beta cells of the pancreas, and the glucagon, another pancreatic hormone produced from the pancreas, and the ADH, antidiuretic hormone, the posterior pituitary hormone, this is also protein, and oxytocin, very important hormone for the letdown of the milk and delivery of the baby. All these are the protein. Adenocorticotropic hormone produced from the anterior pituitary, that is also a protein, and the thyroid stimulating hormone produced from the pituitary, that is also a protein. So follicle stimulating hormone, luteinizing hormone, these are the hormones acting on the gonads, on the ovaries and testes for the reproductive function. All these hormones, they are protein, and they are part of the plasma protein. They are circulating in the plasma protein. And then some enzymes as well. A few enzymes, many circulating enzymes are also part of the plasma protein. For example, alkaline phosphatase is present in the blood. Acid phosphatase is present in the blood. And AST, aspartate amino acid transferase, AST, aspartate amino acid transferase is present in the blood. And then ALT, alanine amino transferase is also present. So different enzymes are also circulating in the blood as the part of the plasma protein. So these are a few functions of the plasma protein. Inshallah, next time I'm going to discuss, next lecture will be on the formation of RBCs or erythrogenesis, inshallah ta'ala. Hope you are following me. If you have got some questions, some problem, you can ask in the comment section. Thank you next time, and subscribe. Well, do subscribe my page to more, other fellows, other students, so that most of the students can benefit from it. Thank you very much. Hope to see you next time, inshallah ta'ala.